we have a firm understanding of how the earliest stars, galaxies, and black holes formed, as well as how the universe developed from an initial singularity 13.8 billion years ago. What, however, took place prior to the Big Bang? In response, Stephen Hawking gave a resounding nothing. After all, the universe's creation marked the beginning of time as well. Some academics, however, hold a somewhat different belief in this regard because, in reality, the Big Bang was only one of many Big Bangs that continue to occur today and was by no means the beginning of everything. On the other hand, this implies that our universe is only a little link in an endless chain of universes and does not in any way represent the larger picture. However, is there any concrete proof that this assumption is more than simply a fascinating theory? Indeed, there is. The very inconceivable conclusion that our world is currently merging with other universes is supported by a new discovery made by the James Webb Telescope. Astronomers discovered something really surprising when they started studying far-off galaxies in the 1920s. The majority of galaxies were heading away from us, they realized. Indeed, this recent discovery has stoked conjecture that the Earth might eventually be the center of the cosmos. However, the specialists quickly learned that not all structures are implicated in this galactic mass exodus, as evidenced by additional discoveries. The truth is that, based on what we now know, the Andromeda Galaxy and our Milky Way are actually merging in a little over 3 billion years. But at first, about a century ago, the galaxy's voyage appeared to be an inexplicable riddle. But after decades and numerous in-depth studies, scientists were able to determine the actual causes of the odd galaxy movements. We now know that, strictly speaking, space itself is expanding continuously, not the galaxies that are traveling through it. However, because there is no central starting point, the expansion of the universe is not exactly as straightforward as it might appear at first. On the other hand, this implies that it seems like the other things are evaporating from you everywhere in the cosmos. It would always seem as though you were in the center of the universe, from where all other structures were running, regardless of where you were looking. However, this discovery also revealed another potentially important fact: the universe itself lacks a stable center. Simply said, cosmic expansion causes everything to move away from everything else. Not only that, but researchers have found that space is growing. In fact, it is expanding at an accelerating rate. In other words, a galaxy moves away from us more quickly the farther it is from us. 97% of galaxies in the observable universe are actually traveling faster than light away from us, according to recent studies. However, how can this ever be possible? This is in direct opposition to Einstein's notion that nothing moves faster than light, isn't it? Not really, though. Actually, Einstein's theory is only applicable in empty space. No cosmic speed limit is breached here, though, because the galaxies are actually at rest in space, and their motion is determined by the expansion of space itself, as was previously mentioned. Interestingly, Einstein himself acknowledged that a speed greater than the speed of light may be achieved within the confines of space. The mysterious history of the Big Bang. Most astronomers believe that the Big Bang marked the beginning of cosmic expansion. Given that space was created from an initial singularity together with matter and time, this is hardly surprising. What may have been the expansion of something that didn't yet exist? We frequently think of the Big Bang as a violent event in which the universe literally burst into existence, despite it being the frequently spoken beginning of everything. This suggests that 13.8 billion years ago, at an unfathomably hot and dense point, the foundation of everything that exists now existed in the past and will exist in the future lay dormant. The comparable singularity could now be thought of as a tiny dot in the so-called nothingness. However, how does this relate to the idea that the cosmos is limitless? According to some scholars, the universe must have been infinite from the beginning, even if it is now. In other words, the Big Bang occurred everywhere, rather than in a single location. This implies that the initial galaxies formed everywhere in the cosmos, rather than in a particular area of space. In the same sentence, it seems that matter was present everywhere in the universe at one time. Nevertheless, there are still some important problems that remain unresolved by the widely accepted theory of the Big Bang. What, after all, was the reason behind something's abrupt appearance 13.8 billion years ago? How is it possible for something to emerge from nothing? And was it all a coincidence, or was there a trigger? We just don't know the definitive answers to these important concerns, which have long been the subject of intense professional dispute. In summary, not all of the universe's features that we can now witness can be explained by the Big Bang theory alone. Among these are the universe's isotropy, or the property that it always appears to the observer in the same manner, independent of the observer's direction of spatial observation, inflation in the cosmos, and dark energy. This is the point at which cosmic inflation becomes relevant. The cosmos is believed to have expanded incredibly quickly during this epoch, which came right after the Big Bang. During this time, the cosmos changed from being very little to being much larger in less than a trillionth of a second. However, what was the force behind this elemental process? Scientists point to dark energy, an enigmatic component whose origin is mainly unknown, but which is nonetheless thought to be responsible for the universe's accelerating expansion. We do not yet know whether there is a true connection between the dark energy of that era and the dark energy of today, despite the fact that dark energy and related forces may have contributed to the onset of cosmic inflation. As previously stated, dark energy is thought to be the primary cause of the universe's accelerating expansion in contemporary space science. Even though this enigmatic energy source has been firmly established in the field of astronomical research for more than 25 years, experimental evidence for its existence has yet to be established. In light of this, some scientists think it's possible that the faster cosmic expansion is being caused by something we've only heard about in wild science fiction movies rather than dark energy. Unbelievably, a study that was published in the Journal of Cosmology and Astroparticle Physics on December 12, 2023, comes to the conclusion that what our instruments believe to be the universe's expansion may instead be the product of universe mergers. Mergers in the universe and the Hubble constant. We must first take a quick digression into the realm of the Hubble constant in order to comprehend the context of this unusual claim. In essence, it shows the present rate of expansion of the cosmos. Regretfully, though, it simultaneously embodies a massive mystery. When the Hubble constant is calculated using cosmic background radiation, the result is 67 chem/s per megaparsec. But when scientists consider variable stars, so-called Cepheids, red giants, supernova, and gravitational lenses, the Hubble constant abruptly drops to 73 chem/s per megaparsec. To put it another way, the cosmos is expanding far more quickly than it ought to. However, how is that possible? Space should be expanding everywhere at the same rate based on our assumptions. One possibility could be that previous measurement results were tainted by mistakes and inaccuracies. The James Webb Telescope recently conducted a careful examination of 320 Cepheids to determine whether this is indeed the case. The results were depressing but unmistakable. The previously noted deviations are consistent with reality. Thus, the Hubble constant mismatch is real. However, what explanation is there? The principal author of the study in physics Nobel winner Adam Reyes suggests that we might have a misunderstanding of the cosmos. Stated differently, the mainstream cosmological model may not account for forces and processes that exist in the world. For example, this might be an unusual sort of dark energy or dark matter, but it could be far more revolutionary. Was another universe consumed by ours? When it comes to the Hubble gap, Jan Amjayarn of the University of Copenhagen thinks it's better to ignore dark energy and instead think about the potential that our world is merging with other universes right now, and not only yesterday. It is believed that the true cause of cosmological inflation is that our universe has been consuming its mother world, just as our youthful cosmos was once absorbed by a larger parent universe. Once absorbed, it collided with other infant universes, eventually absorbing them as well. However, how can one even generate such a notion? By developing a mathematical model that investigates the potential impacts on our universe of several interacting universes. According to the specialists' calculations, the merger of worlds would result in an increase in the volume of our universe, which our measuring devices would then perceive as an expansion of the cosmos. That's not all, though. Simultaneously, scientists calculated the expected rate of universe expansion in this scenario, and the related results actually accorded with space data much better than the conventional standard cosmological model. The evidence-seeking process. Only actual observational evidence can validate even the most amazing idea. However, how do you initially notice a distinct universe? No, not at all. Many tests are now being carried out by professionals to study the microwave background in order to evaluate the theory of the merger of universes. Therefore, there may be some unidentified features in this radiation remnant from the immediate aftermath of the Big Bang that could eventually help us connect with other worlds. Additionally, you should hit the thumbs up and subscribe buttons right away if you wish to regularly watch our movies. Become a member of our community to stay current. See you soon.